and welcome to Common Core Algebra 2, 3.1 Direct Variation. We begin our linear unit by looking at the simplest linear relationship that can exist between two variables, namely that of direct variation. We say that two variables are directly related or proportional to one another if the following relationship holds. So taking a look inside the box here, and again, this is what you really should be writing down and taking notes, because this is what I will be checking for to make sure you watch the video. So two variables, we'll call them x and y in this example, have a direct or proportional relationship if for every ordered pair xy, we have y over x equals k, or if you simply cross multiply, y equals kx. Now k is basically a constant of some type, whether it's an integer or a fraction or a decimal. It's some relationship, it's some type of a multiple. So y is going to be some multiple of x. So the value of k is known as the constant of variation, but we're just going to call it the constant for the time being. So taking a look at exercise 1. In each of the following, x and y are directly related. Solve for the missing value. So we're going to remember that that relationship we just talked about was y over x. All right? So if you consider that, and I'm going to remind you that that is the constant. All right, so in this situation, it tells you, and I like to leave it off to the side here to remind me, y over x. So 15 over 5 is equal to, create a proportion, y, we don't know what y is, so we just leave it as y when x is 9. So if you take a look here and you cross multiply, we get 5y is equal to 15 times 9 is 90, 135. Divide both sides by 5, and y is equal to 27. Again, when we look at b, again, I like to do that y over x. Now, could you do x over y? Yeah, you could, because as long as you're remaining a constant proportion, you could even do x over y. So y over x, because that's the way we looked at it in our definition. So when y is negative 6, x is 4. We don't know what y is when x is negative 10. Again, cross multiply, 4y is equal to 60. So y is equal to 15. So why don't you pause and give the next one a try on your own. So hopefully you were able to do that pretty successfully. So moving on, exercise 2. The distance a person can travel varies directly with the time they have been traveling if going at a constant speed. If Phoenix traveled 78 miles in 1.5 hours while going at a constant speed, how far will he travel in 2 hours at the same speed? So if we take a look at this, we can see that we have distance, we have time, distance, and time. So here we have distance and we have time. So let's call D1 time 1. While going at a constant speed, how far, so we're looking for distance, will he travel in 2 hours, here's our time, at the same speed? So again, create the proportion. Distance over time. So my distance for my D1 is 78 over my time 1, which is 1.5, and that's going to equal our distance 2, which is what we're looking for, so let's call it d, over our time 2, which is 2. So easy mathematics just tells us, why don't we cross multiply, and we get 1.5d is equal to 78 times 2, which is 156. And after we divide by 1.5, d has to equal 104 miles. Remember, always check and make sure it makes sense. We're asking how far. Answer the question. How far will he travel? 104 miles. Something should not sound right to you if you come out with something, with hours behind it. So looking at exercise 3, Jenna works a job where her pay varies directly with the number of hours she has worked. In 1 week, she worked 35 hours and made $274.75. How many hours would she need to work in order to earn $337.55? So again, this is where annotating really comes into play. Jenna works a job where her pay varies directly, so we have pay and we have hours. In 1 week, she worked 35 hours, so here's hours 1, and she made, what should we call it maybe, dollars? Dollars 1. How many hours would she need to work in order to earn $337.55? So that's dollars 2. So that we want to know, here's our hours 2. So again, hours over dollars. Could you set it up the other way? Yes, of course you could. Dollars over hours, as long as you're making sure your proportion stays consistent. So hours 1 is 35 over D1, which is 274.75, equals how many hours? That's what we're looking for. So we'll call that H. You could call it any variable you wanted to, over 337.55. So we cross multiply, and if you take a look at this, it would be basically taking a little bit of a shortcut. H would equal 35 times 337.55 divided by 274.75. And when you're all said and done, H turns out to be 43 hours. We will now examine the graph of a direct relationship and see why it is indeed the simplest of all linear functions. So exercise 4. Two variables, x and y, vary directly. When x equals 6 and y equals 4, the point is shown plotted below. It's right here. Find the values of y for each of the following x values. Plot each point and connect. So again, if we go over and we do y over x, all right, so if we keep that in mind, we're looking for the y. Remember our original one. Our x is 6 and our y is 4. We know x is 3, so over on the right-hand side, we're going to put that x is 3 on the bottom, so it corresponds to our 6, and we're looking for our y. So cross multiply pretty easily. You can see 3 times 2 is 6. So what times 2 is 4? So y is equal to 2. Can you cross multiply and do this the long way? Absolutely. But it is not that hard to figure this out. Now, so that point is, now we're saying y is 2, but what is my actual point? The point is x is 3, y is 2. So 3, 2 sits right here. Keeping that same thought, we have y over x. I just put that there to make sure we're being consistent, because I don't know about you, but sometimes I forget where I put things. So x is 6, so x is 6 when y is 4. And now we have here x is equal to negative 6. So that's down here. So I think it's pretty easy for you to see that the relationship would make this negative 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So if we did this properly, we should be able to take a line and make sure it goes through each of those points. Then it says, what is the constant of variation in this problem? Well, we know what the constant of variation is, right? Because basically we know it's going to be 4 over 6. But if we reduce it, because we always like to express our final answer in the simplest form, it's going to be 2 over 3. So what does this represent on the line? So if we're thinking about the line being an equation, we know the equation of a line is y equals mx plus b. And what part of the equation does this 2/3 represent? So up 2 over 3, up 2 over 3, up 2 over 3, up 2 over 3. So I'm hoping you're realizing that the 2 over the 3, which is equal, the constant, is equal to the slope of the line. So now it says write the equation. Well, keeping that same thought from up on top, we know it's y equals mx plus b, so y equals 2/3 x. Now, it goes through the origin. I can add the plus 0 in here. That's okay to do that, but if this is a multiple choice question, this will be missing. So I'm hoping by the time we get into Algebra 2, we don't have to put the plus 0, and the origin or the y-intercept being 0 is just implied. Remember, you should be pausing this video whenever you need to be taking notes. So in exercise 3, it says direct relationships often exist between two variables whose values are 0 simultaneously. So what I want you to do is try to read through exercise 3, see if you can keep in mind what we've talked about so far, and see if you can answer the questions. All right, and then we'll come back together and we will put the answers up together. hopefully, again, you were successful in calculating what was asked for. If there's any questions about any of this, you should be putting a star in your notes and making sure you're asking them the first 10 minutes of our class tomorrow. So direct variation is very important and used very often in real life situations because they form lines. They create arithmetic sequences. They create a constant increase or decrease. We use this all the time in life. All right, so we're done with this lesson for today. Have a good one, and I'll see you again tomorrow.